n is equal to c, or sorry, c arrow next, and c is equal to c arrow next. So something like that. So we have a pointer pointing to the current node, we have a pointer pointing to the next node, right? If that's the case, if we end up with such situation, now it's very easy. We're gonna say that c arrow next is equal to n arrow next, right? So this is gonna move to here. And now I do have a pointer pointing to the node that I want to delete. I'm gonna say delete n. This is gonna be deleted. Okay, so sometimes the solution is to have more than one pointer for traversing. One to look at the current node, one to look at the next node, right? In this case, this was used to delete this node. In some cases, you might actually need 3 pointers. You want to see an example that we need the current, next, and previous. We want to see an example later. Okay, so now actually let me write a code here. Let's say that we want to write a code that searches through the linked list, and the first number 5 that it finds it wants to delete it. It wants to delete that node. Okay, so it's again deleting a node, but it's a little bit differently. Okay, so again, I'm gonna have 2 pointers. One is let's call it current, one is called temp. Okay, I have on my head pointer, and I wanna delete this one. Okay, so I'm gonna write a while current is not equal to null and current arrow data is not equal to 5. So while I haven't reached the end and while I haven't find this, traverse through the linked list. T is equal to C, C is equal to C arrow next. Okay, so we move both of these pointers, it's gonna stop right here. This time this is C, this is T. Okay, so in this case we have both pointer to the node that we want to delete and to the previous one. Okay, same as what I showed you last time, right? So if that's the case, first of all we check if C is not equal to null, means that okay, if actually this number exists in the linked list and we want to delete it, what do we have to do? What do we have to do? You guys tell me. What we want to end up doing, we basically want to end up saying that C is equal to C arrow next. Okay, sorry. In this case, we basically wanna delete this one, right? So we wanna say that T arrow next is equal to, this is T arrow next, is equal to C arrow next, right? and then just delete C. Okay, so that's one way of solving the problem. Okay, I want you to verify this code and make sure that it works for deleting the first node, last node, and middle node. And it also works for empty list. It works for the case that the target exists or doesn't exist. So you see that this is like what it's involved in testing a code. You have to test it for different scenarios. Do we have 5 in the linked list? Do we not have it? Is it in the first one? Is it in the last node? Is it in the middle node? Can our linked list be empty? Okay, so make sure that you change this code accordingly so that it works for all of these scenarios. Okay, that might involve having another pointer. If you have to, you have to. Okay. So all these codes are given to you in the PowerPoint file. You can refer to them. Please practice them yourself though. Please write them yourself, then look at the solution. Okay, now I wanna do a relatively more challenging problem. Okay, this is current. What I want to do, I want to reverse my linked list. Okay, right now it goes from here to here to here to here. Want it to go the other way around. Sounds very challenging, right? Okay, there are 2 ways of doing it. You can do it recursively. We're gonna talk about that later. Now I'm just gonna do it non-recursively. Okay, so let's look at how this can be done. This is the scenario that you actually need to have other pointers. Okay, so we usually just like needed 1 pointer to traverse through the linked list, right? We would just write a loop saying that while current is not equal to null, right? This is null. Okay, now what I'm gonna do here, I'm gonna say that next, so first of all we initialize current with head. Now we're gonna say next, let me actually call it just